All right, next up, we got to make the caps for these guys here. And they're going to be made out of this aluminum that I've already dimensioned. And one of them is a piece of steel. And I actually don't know what the alloy is, because it was a piece that I had that I never knew, was just unmarked. When I get all my steel in stock, I always mark it. But this stuff was unknown from the get-go. So this is going to be the drive piece. And then the other ones are going to all be idlers. So I have bored out the jaws here to fit this. And they're about 200 thousandths deep, which leaves me some extra material because I have to go in 1/2 inch on this guy. All right, so we just want to create a little relief section here that's going to fit inside the tube. That will provide areas for the through holes to go through for the screws that bolt these on the end pieces here. So we're we found our zeros, and now facing off the flange. A little bit of undercut for clearance, and I think we should be good. The last step will be to mount this back in and remove the excess material off the ends here to make it the same diameter as this, because this is a full 4 inches and this got reduced down about 60 thousandths here at the edge. So we'll need to do that. But before we do that, let's drill a hole through the middle, because that's necessary for the shaft to go through. And we're just going to chamfer the hole gently. And we'll try a test fit. That's a really nice fit. This piece will stop from sliding in by hitting this, although it should be rotating with the shaft, so there doesn't need to actually be any differential motion between these two, because remember, on this side there's going to be the keyway. That's the cap we're making next. So this is the aluminum end that is the free end. The other side will be the keyed end, and that's the one we're going to make next, and that one will be out of steel, so this is a really good fit. Next up, we need to do the same thing with the steel one, and this guy will be getting a key ultimately, but other than that, it's identical to the one we just did. We just finished the 2 end pieces for the drive wheel. Now we have to do the 2 pieces for the idle wheel. So we have to reduce the outside diameter so they fit inside just like the other ones, but these also have a bearing on them, which you can see here. So we got to do a bearing pocket. We've machined out a pocket for the bearings, but I just want to add a little bit more relief for this center bit. So I'm just going to go down like 15-20 thousandths and go over so that there's no chance it'll rub. An extra 10 thousandths into the middle, and then I know that it won't be rubbing. So this can spin freely when I hit it in, or when I press it in rather, sorry. It's a good press fit right now. Goes in, it's not coming out. On the freewheeling hub, I have pressed in the bearings, and that'll give me an accurate center at exactly 1/2 inch diameter. So now I'm going to make a couple of mandrels to hold these parts in the mill so that I can drill the 4 holes to mount them. And I've done that with both of these guys that are the idlers. Next up, we have a couple pieces of scrap aluminum right here, this one and this one. Actually, I might have to find another one, this one, because I don't know about those threads. But here's the deal. Drill and tap the center. I was going to do 1/4 20. Maybe this one's large enough to do 5/16, 3/8 maybe, I don't know, we'll see. Got to make mandrels that'll be 3/4 inch and 1/2 inch, and they're going to be used to support these parts while I drill the 4 holes in the outside. over on the mill. And I just wanted something that I find center once and I'll be good for both parts. So that's where we're headed. Just removing the excess material off the front. I don't need to take it all off. So we're doing roughing right now, so I'm going to take some pretty big bites. We're going to go in a total of 1.4, and then we'll finish the last bit. If you're wondering how it's going to work, take the ball bearing that auto centers, slide it on, pop in a screw, tighten it down, and we'll be good to go. I'm just going to give a little bit of a crank here. Sorry about the focus, it's searching, but tighten this down a little bit and we'll be good to go to drill our 4 holes. 4 holes, 1 in each quadrant. Here's the 3/4. Gonna fit on like that, no wiggle at all. 3/8 16 bolt. Tighten it down, good to go. Heading over to the mill. To get my center quickly fairly close, I put a 60-degree bevel and I have a 60-degree center. I made these in various sizes so that I could do this easily, and this gets it within a few thousandths, which is probably more than enough accurate, but I'm gonna pop an indicator on there just for my own reference to see how close it is. You start with 3/4, and I actually made 2 of these in case I wanted to drive from both sides of the cylinder, which I hadn't decided on yet, so we'll see about that. So it's easy to do quadrants. We're drilling 1/4-inch holes and we're going over 1.781. You can see right where that's at, 1.781. It's kind of a little bit fast. Sure to lock your axes. Hard lesson to learn. So I'm only moving on the y-axis right now, so I've locked the X at 0. Last time I bumped it with my knee and it was off 25 thousandths. And that's 1 down. And just rinse and repeat, both mandrels, all 4 parts. Quick as that. So the part that I hosed here, I just clocked it roughly 45 degrees and drilled a new set of 4 holes. These 2 are no good, these 4 are right on the money. And if you're wondering how I deburr this, let me show you. The beauty is the mandrel itself is doing most of the work. The screw has to do very little, so the bottom part is pretty sharp. So the top, got the Tom Lipton solution, one of these deburring hex shank tools made in Germany. Just quick run through. Wonderful, wonderful thing Tom brought up there, and I'll show you how I do the back. The back's pretty gnarly. I'm pretty sure I've shown this before, but see, there's not enough room to get the deburring tool in there, even a smaller one that I've got. So this Cogsdill deburring tool, you just pop it through and get the rear. You can actually do both sides with it, but if I just want to do the back, and I only have this in a couple sizes that I got in an estate sale, and I didn't even really know what they were until I started using them, then fell in love with things. I have 1/4 and 3/8. I think it'd be worthwhile getting commonly used sizes because they do a great job deburring the backside of a hole. All right, all done. Here's the 1/2 inch ball bearing ones. This is the second one of those done. Still need to deburr it. One thing, originally I was going to use 1 1/4 stock because I have a ton of it from another project left over, so I could easily, stand to lose some of this. But I wanted a wider stance because this way and this direction, not so big a deal because the vice jaws are holding it. But this direction with smaller stock, it might want to lean a little bit. So I made a bigger platform so that it's more stable on the base. Alrighty, so I wanted to broach both of the parts together. So besides bolting them together, I used 2 bolts and 2 pins. And I didn't ream these holes, but they're actually accurate enough that they're going to work together. They're going to broach together. Now you have to be concerned a little bit about the maximum depth of cut of this broach. I think it'll do 1.5 inches. I'm not 100% certain, so we got to make sure we're okay there. Otherwise, we could have some problems. And the reason I want them both the same is I can clock them 90 from each other. It just depends on what I decide to do with the shaft. So we're going to start with just putting 1 key slot in the shaft, but I may want to add a second one. Okay, this is where the thickness might cause a problem. So we passed the broach through once and we've got a bit of a cut, but I think I need a little bit more than this. So I'm adding a shim to it, and then we run the broach through again, and the shim makes a cut just a little bit deeper. And each time I got to make sure that the broach clears on the bottom. So there's the keyway both sides. Perfectly fits the key stock here, nice and tight. Next up, we got to trim down the end caps because I left them full diameter and the ends are obviously tapered down so they're smaller. So what I'm going to do, I've got the mandrel in the middle, and we're going to screw the end caps on and we're going to turn them down, and hopefully I left enough margin. I may not have been adequately careful when I planned this out. I may have needed the screws offset a little bit more to the inside. Then I just make sure I've got this indicated in, and fortunately the holes in the end are big enough for the Allen wrench so I can sit here and manipulate this guy until it's mostly true. And we're just gonna pop our tool on the end here. What I'm really hoping here is that I'm not gonna hit the screws, but I think I'm going to. I think I'm gonna cut them down a little bit, which is unfortunate. I did not plan that adequately, did I? Once I realized I really didn't have clearance for the screws, I decided to switch to these screws, hoping they're softer than the other ones, although I don't know, they're alloy screws too, they're zinc plated. So I also switched to a different insert because it's going to be a nasty interrupted cut. So I guess we just give this a shot, huh? I suppose I could use a left-handed cutter and come in from the backside, but And that's all we need. And then what I'm going to do is I'm going to mark each one. That's good transition there. And I'm going to mark each one so that it matches up with the side it goes on. I'm also going to have to deburr these because it's turning up a nasty burr, and we'll just consider these screws sacrificial, and I'll have to order some that are lower profile than these. I thought I had them, but I don't. Then you unscrew the ends off of here, and take this off, flip it around, and rough this into place. Get the screw the end on, dial it in, and do it all over again. So here's the end that's going to go on this side. Might as well use the same sacrificial screws. Wow, it almost lined up. Next up, same story, doing the 3/4 with the steel. I'm going to do both steel ends. And what I'm doing actually now is I figured out after, if I mark the side and I keep the screws in the exact same location, they're perfectly rounded off. So I'll just use new screws each time and have a matched set of screws and match this. That'll work in the near future until I can find some smaller diameter head screws, like normal cap screws. Identifying the center of the slot. First step in doing the key slots on the drive shaft. And I still am up in the air about my drive shaft design. I originally went with, you can't see it over here, but on the far opposite side, the main drive shaft is only 1/2 inch diameter. I think I should have gone at least to 5/8. That might have been a mistake on my part. So we may be making this shaft from scratch at some point and replacing some bearings with some larger bearings. Next up, we're going to go in 150 thousandths. This is a center cutting, I am hoping. It looks like. We're in about 100 thousandths. Let's clear the channel. All right, I'm going to drop this guy out, and I'm going to deburr the edge and see if the key works out. So the key fit is really tight, so I made this mini key here that'll go all the way to the bottom, and it's actually a little bit narrower so that it doesn't stick so tight, because when I put that key in, it's going to be nice and tight in there, which is good. But I need to find out my final depth, because I sort of just guesstimated, because the shims I had, well, I just have lack of experience, so I didn't plan the proper depth. And so we need to go in a little bit more. And I'm using this guy to tell me, so we're going to take off another 20 thousandths of depth, and we're going to retest. We got ourselves a scary close fit right here. In order to get this to go in, I have to tap it in. So what I think I'm going to do is I'm going to go for just another 5 thousandths to allow a little bit of clearance, and we should be good to go. Then we're going to put another one of these slots on this side in case I ever decide to drive it by both sides. I'm sorry, I need to put a slot down here on this 1/2 inch end. This is where the pulley goes, and I'm a little concerned that 1/2 inch is not enough meat, even though it's 4340 stock, so it's pretty damn strong. I may have underestimated the diameter I needed, and I might need to switch up to 5/8, which means I have to remake this whole bar, and I've got to bore out a hole and get a larger bearing. And anyways, so we're going to stick with a 1/2 for now and see if it works. But I do have a 3 horsepower motor driving this, and that may be completely inadequate. We'll find out. I'll go look up and see if I can find out what size shaft diameter they expect, or that is expected. Okay, we got 2 keyways in case I wanted to add the second one. This way they're both lined identically. So we'll do a test assembly really quickly. So I've got one end, oh, I didn't even screw it on. I've got 2 ends to screw on this one. Pop the shaft in, you can see the bearings already preloaded in these guys right here. This is the idler wheel. Now this one's not done because there's going to be a pin through this one that allows it to pivot for centering adjust. So that will be there, and this will be here. There you go. And I did put marks on these to line these up. That one, and of course didn't put the marks in the same spot. There we go, and then this side. And so it spins freely, and there's absolutely no play whatsoever. I mean, that's this end pushing out. When it's in, it's really nice and very smooth. So we're good on that one. Like I said, there's a little more work to do on that one. And then this one, which has the clearance hole on one side. Right now, I've just got the through hole on this side, which ultimately may be replaced with the other steel one I did to use a key. But in the meantime, we're just going to let the key sit through there. I'm not going to put the key on this because I have to take it apart. But as you can see, very nice fit. There'll be the key lined up. Now this one will not free run. This is the drive pulley. This is on the bottom. And I think what I did notice here, aha, a little bit of play. So I have to make a shim inside because I don't want this thing bouncing around at all, because movement causes wear, and wear is the enemy. So we're going to have to figure out how much wear, how much movement that is. And then we're going to need to shim it. A mistake was made somewhere, but we've got an indicator. We got it gently clamped in my mill vise. It doesn't really reach the halfway point, so it's not moving anywhere, but it's not, it's not a really good tight fit. And all I've got is an indicator on the center, and it's all the way back this direction. So now I'm going to push it out, and lo and behold, 17 thousandths of play. Yep, a little tiny bit over 17 thousandths. So we need to make a 17 thousandths shim for this guy. I don't know where my error was, but and right now the shim won't be on the key stock side, or I have to put a key slot in the shim, which is probably not impossible, but let's start with the easy side since I'm not currently going to put a shim in this side. So I've got some stock here. We're just going to make some shim stock out of this. And we're good. Gives me 2 options. I'm going to try and put a keyway in this guy, and if I can't get a keyway in easily, then I've got enough 3/4 inch material there that I can use that to make a shim all by itself. So again, we're going to take the slug that we just cut off with a 3/4 inch hole, and we're just going to broach through it. I've got 2 spacers there like I did before. And we just need to part off a section of this and see how it goes. Because it's going to be an interrupted cut, I have my concerns. Because that's going to be a very thin section sticking off there. But let's see how it goes. Maybe we'll offer a little bit of lube to this. Probably could have used a thinner parting tool. There's our interrupted cut. So far, so good. Okay, seemed to come off all right. So I just got to take this piece off here, clean it up a little bit, and probably sand it down because I left it just a little bit large, and then we'll get it to 17 thousandths and give it a try. I made this about 1,000th over. This is a Starrett pink granite surface plate that I bought specifically just for this. I got a really good deal on it for sanding, and I lubricate it with isopropyl alcohol, which seems to work pretty well. It stops it from loading up, and I can wipe it off, and what I don't wipe off evaporates. And since I can't get even pressure on it, what I've been doing is I've been clocking it like 90 degrees, doing a lap, clocking it 90 degrees, doing a lap, clock it 90 degrees, do a lap, and we should be right there. We were a couple tenths off. It's not perfectly flat because of the parting. I would have needed to leave a lot more material and then gone through a bunch of different grits of sandpaper, but this is a shim, so it's not going to matter at all. So let's just give this a test fit. Alrighty, so we finished this guy, as we saw before. That guy spins nicely, everything's great. This one needed a shim, so I made some non-keyed, some keyed shims. I made a couple extra of each. There's the non-shim, made 2 keyed ones, plus I have some key stock left in case I need to make another variation. So we're going to use the keyed one, although I don't think I'm going to need it because there's going to be so much support for this, because if I tighten this guy down, the shaft is really snug even without a key, so that's even going to support it. I've got my alignment marks there, got my alignment marks here, and I'm going to walk up in torque on these guys. So we're going to start down here.